Hi everyone, I'm going to be doing question 2 of week 1B homework. So for this problem, we need to figure out where the total electric field is equal to 0. So we have a positive charge on the left and a negative charge on the right, and the problem tells us that the negative charge has a greater magnitude, and that means that it's stronger than the positive charge. So our goal is going to be to find where the electric fields from these two charges cancel each other out. So before solving, I will define all of our variables. So E represents our electric field, which its SI units are newtons per coulomb. Q represents charge, and its SI units are coulombs. R represents distance from the charge, and its SI units are in meters. And K is Coulomb's constant, which is used when calculating electric fields. So also the equation for electric fields is shown here, where E equals K times the magnitude of the charge divided by the distance squared. And this equation tells us that bigger charges create stronger electric fields. And it also tells us that electric fields get weaker as the distance increases. So even though this problem doesn't have numbers, this equation could really help us understand how the fields behave practically. So first I'll check the space between the charges. So it looks something like positive. So E positive would be pointing to the right, and then negative would also be pointing to the right. And the electric fields would point away from the positive charges and towards the negative charges. So and the electric field from the negative charge also points towards the right because fields point towards negative charges. So since both fields point the same direction, they add together. And I should maybe add it. And so they cannot cancel here, so the answer is not between the charges. Next I will check the region to the right of the negative charge. So it would look like the right side of the negative charge, the electric field, the positive electric field would be pointing to the right, and the negative electric field would be pointing to the left. And so here the fields point in opposite direction, which means cancellation could seem possible, but any point on this side, but the negative charge is stronger than the positive charge, and any point on this side is also closer to the negative charge than to the positive charge. So the negative charge's field would always be stronger here. So that means electric fields cannot become equal, so they cannot cancel. So now we could check the left side of the positive charge. So here the electric fields would point in opposite directions because the positive electric field would be pointing to the left, and the negative one would be pointing to the right. And since they're opposite, cancellation is possible, but the negative charge is stronger. But as we move farther to the left, the negative charge becomes much farther away. So eventually the stronger negative charge can be balanced by its greater distance. And so that means there is one point in this side where the electric fields have equal magnitude and cancel each other out. So the only location where the total electric field equals 0 or is to the left of the positive charge is to the left of the positive charge. So the fields between the charges add together so they cannot cancel there. And to the right side, the stronger negative charge always produces a larger field. So only to the left side of the positive charge can two fields become equal and cancel each other out. So the correct answer is to the left of the positive charge. To the left.